We are going to go over some examples of monohybrid Punnett squares. That means that we are going to calculate the genetic probability for one trait being passed from parent to offspring. All right, so our example is in Elmo's family, red fur, capital R, is dominant to blue fur, lowercase r, because remember we used the first letter of the dominant trait, which is dominant to blue fur, which is recessive. Complete a cross between Elmo's heterozygous parents. Right, so we know that both of his parents are heterozygous. Just as a little reminder, I always type the letters the way that you would write your alleles. So if his father is heterozygous, we're going to give the father a capital R and a lowercase r. And it's just good practice to underline your lower cases for when, you know, the capital and lowercase kind of look the same. And then the mother is also a capital and a lowercase. We're going to go ahead and put the parents on the box outside edges. Personally, I put the father at the top of the box, so capital and lowercase, and the mother off to the side of the box. Now what we're going to do is we are going to kind of transfer the alleles into each box, and we want to make sure that anytime we have a capital letter, whether it's from the mother or the father, doesn't matter, we write the capital first. Just like if you write your name, the first letter should be capital. You don't put a capital towards the end. All right, so we're going to transfer that. So now father gives a capital, mother gives lowercase, father gives lowercase, mother gives lowercase. And now it's time to analyze. So HD would be two capital letters. And out of our Punnett square, we have one box that has both capital alleles. That means 1 out of 4 of those boxes is homozygous dominant. And 1 out of 4, if you think of quarters in a dollar, 25%. For our heterozygous, we're looking for a capital and a lowercase. We have 2 of those. So 2 out of 4. And that ends up being 50%. And then lastly, HR is lowercase, lowercase. We have 1 out of 4, or 25%. For the second half of the box, we need to put the phenotype. So the phenotype is what the appearance is, the physical appearance. And we know that the dominant is red fur. And the recessive is blue. What I like to do is I know that whatever my HR number is going to be the same as my recessive. So the bottom line is going to stay the same. And then for my HD and HE lines, I'm going to add them together. So 1 and 2 makes 3 out of 4. 25 and 50% together make 75%. So let's do one more example. So Oscar has a brown unibrow, lowercase b, which is recessive to a black unibrow, which is dominant. Oscar, who is HR, and Grangetta, who is HE, are expecting their first child. Complete a cross between the two. So Oscar is HR, that means he's going to be lowercase, lowercase. And Grangetta is uppercase, lowercase. We're going to put them around the Punnett square. So Oscar, I'm putting at the top of the box, and Grangetta, I'm putting on the side of the box. And now I'm going to transfer my alleles into the Punnett square. So Grangetta gives a capital, Oscar gives a lowercase. Grangetta gives a capital, Oscar gives a lowercase. Now they are both giving lower cases, and both lower cases again. If we look at our 4 options, none of our boxes have capital capital. So that's a 0 out of 4, or 0%. 2 of our boxes are capital lowercase, so 2 out of 4, which makes 50%. And then 2 of our boxes are lowercase lowercase, also making 50%. Looking at the word problem, we know that brown is recessive to black. Again, whatever our HR is going to look recessive. So I'm going to keep that line the same. The bottom line is going to stay the same. And for our dominant, well, we don't have any HD, so it's just going to be the HE line. And now we have completed their cross. So that means that if they have a child, there's a 50% chance that they have a black unibrow or a 50% chance that they have a brown unibrow.